Welcome to the Ambient tutorial videos. In this video, I'll be talking about timecode. One of the most common misunderstandings is that timecode and synchronization describe the same thing, but the fact is they are very different, yet equally important. For an explanation of sync, please watch our detailed synchronization video. Now for our main topic. Timecode is the most important piece of metadata for modern digital workflows, and if you treat it right, it can save you a lot of time and money in post-production. Timecode was defined by SMPTE in 1967. The goal was to create a set-spanning reference for multi-system workflows that includes multi-camera shots and separate picture and audio sources. When done properly, Timecode Workflow replaces the time-consuming task of manual alignment with precision, automatic alignment, executed with the click of a mouse. The idea is fairly simple. Each frame gets a unique number. You could compare it to an individual postal address so that everybody in post-production can find that particular frame just by referencing the timecode. When this reference is simultaneously recorded on all devices, all corresponding frames get the same address. Even though there is only one SMPTE timecode, it can be stored in different ways. When tape was the standard, it was stored as vertical interval timecode, or VITC. As most cameras manufactured today store file-based clips, timecode is stored as metadata in the video file. And now, the audio world. In today's professional workflow, the timecode reference in modern production audio recorders is also stored as metadata, but in broadcast WAV files. Yet it is still distributed as longitudinal timecode, or LTC, as it was when tape was the standard. As this is a linear, or continuous signal, it adds versatility to production workflows as it is possible to record timecode like a standard audio signal on an audio track of a camera that doesn't have a timecode input. This makes timecode-based synchronization possible using video files captured on a variety of devices. And last but not least, there is MIDI timecode, which is most commonly used with audio sequencers. Even though MTC is not SMPTE, it can be translated into all SMPTE formats. Now we've come to the topic of different frame rates. This topic can be confusing as it often confuses professionals that use it every day. The world is separated into two different timecode areas: the European-influenced PAL area and the American-influenced NTSC area. In regions of the world where PAL is used, television productions run timecode at the speed of 25 frames per second and feature film productions at 24 frames per second. In areas of the world using the NTSC standard, television productions run timecode at 24 frames, or most commonly 30 frames, but at the time interval of 1 second plus 1 millisecond. That's 1/10 of 1% slower than the European PAL standard. As broadcast companies require reference to conform NTSC television frame rates to real-time, SMPTE came up with different solutions. The first solution is to incorporate Drop-Framerates, which omit select frames to approximate a standard 1-second time reference. So when using 29.97 drop, 2 frames are dropped every minute, except every 10th minute. This caused a lot of confusion and problems during post-production, as a changing time constant makes it impossible to conform drop to non-drop timecode. With the second and most widely accepted solution defined by SMPTE, production cameras, audio recorders, and timecode generators operate at the speed of 23.976 or 29.97 frames per second to capture 24 or 30 frames while maintaining the NTSC standard. For example, when shooting in the NTSC area at 30 frames, you're actually shooting at 29.97. So if you switch the audio recorder to 29.97 frames per second, they will align perfectly in post and everyone will be happy. And don't use drop frame rates if you can avoid it. Beware, if you are shooting in Europe or you want to shoot a 24 frames per second feature film production on a television cam, make sure the camera is set to PAL. Otherwise, the displayed 24 frames could actually be a 23.976 frame rate. In any case, you should carefully read the camera manual. To learn how different devices are synchronized, please watch the ambient sync video.
Fresh.